In one-dimensional calculus, there is an important relation between differentiability and continuity, namely differentiability at a point implies continuity at that point. But things are more complicated in higher dimensions, so let's look at the function f of xy equals 0 if xy is not equal to 0, and 1 if xy is equal to 0. So xy equaling 0 is equivalent to saying that this is on the x or y axis. One of these two, one of x or y is equal to 0. So here is the graph of that function. Now, let's observe we can see that, observe a few things. So 1f is definitely not continuous at 0, 0. Because if we approach, we get limit 0 if we approach, say, along the line y equals x, but 1 if we approach along the x or y axis. However, we can also see that that the partials of f with respect to x and y are defined at 0, 0. And so the problem we can see in this situation is that we are only probing the function in these two directions, x and y, is not enough to really see the full behavior of this function. Whereas if we were approaching it, taking the derivative along any other direction, like a line such as this, then that would be detecting this discontinuity. Okay, so let's make the following definition. We say that we say f of xy is differentiable at a point x0, y0 if we'll require that the partial derivatives exist. So this is a start, but what we'll also need, and if we set delta, it's called delta z, this is f of x0 plus delta x, y0 plus delta y. This needs to satisfy an equation of the form, so delta z is equal to fx x0 y0 delta x is fy x0 y0 delta y plus epsilon 1 delta x plus epsilon 2 delta y, where epsilon 1 and epsilon 2 go to 0 as delta x and delta y go to 0. And so here we can see why this why this function doesn't satisfy this definition. So we're going to have delta z at the point 0, 0 is equal to -1, but then so the derivatives, the partials at the point 0, 0 do exist, but then this delta z is always going to be -1, and it's not going to go to 0 as delta x and delta y go to 0. And then with this definition of differentiability, we have this relation to continuity. So proposition, if the partial derivatives fx and fy are continuous, these are continuous. And notice in this case, the partials at other points other than 0, 0 are not defined, or they go off to infinity. Then f is differentiable. 0, y, should say at x0, y0. And so in particular, now this is enough to guarantee if f is differentiable at x0, y0, then f is also continuous there with this definition of differentiability.